Bouvet Engineering Limited provides services to the customer for the development of sugarcane crop, including the preparation of land, development of seed, cultivation of crop, application of biofertilizers and organic fertilizers, development of irrigation facilities, harvesting methods, and transportation system of the cane crop to the processing facility. Company also executes sugar manufacturing plant from cane sugar along with cogeneration, alcohol and ethanol on EPC basis including civil work. We provide training to the staff of customer and also operate the plant on their behalf as per the requirement. Company also works for Department of Atomic Energy, Nuclear Power Corporation of India Limited, various defense laboratories and Indian Space and Research Organization. Company also works for oil and gas sector, supplies equipment to original equipment manufacturers of cement, steel and paper industry. Bouvet Engineering Limited, Unit 1 and 3 are located in Satara, Maharashtra, and Unit 2 is in Yamunanagar, Haryana. Our regional offices are in Pune, Chennai, Delhi and Yamunanagar. Late Lala Kailash Chandra, a great visionary and philanthropist, is the founder of K Group of companies. Bouvet Engineering Limited was incorporated on 4th October 1993. Company is having technical tie-ups with renowned companies in various fields. Institute of Natural Organic Agriculture for agricultural activities. Jean Boy and Associates, USA for complete EPC projects for Lotus Rollers and Massacute Filter Typhoon. Industrial Del Hero for cane milling plants. Reunion Engineering Limited at Brazil for alcohol and ethanol plants from cane juice as well as molasses. BMA for cane diffusion plant. Pacific Boiler Design and Construction for high pressure boilers. The company is supported by a consortium of the banks: Exim Bank of India, IDBI Bank, Bank of Maharashtra, Oriental Bank of Commerce and Dena Bank. Company is having registrations with National Cooperative Development Corporation for Turnkey Sugar Projects, Commissioner of Sugar Maharashtra for Alcohol and Ethanol Projects, Nuclear Power Corporation of India Limited, Department of Atomic Energy, Bharatiya Nabhikiya Vidyut Nigam Limited, Bhabha Atomic Research Center, Defense Research and Development Organization, Armament Research and Development Laboratory, Oil and Natural Gas Corporation, ISO 9001, 2008 and AS 9100C for Quality Management, Directorate of Steam Boilers, R&U stamp by American Society of Mechanical Engineers, the quality policy of company. Our quality assurance plans are: Bouvet Engineering Limited is having following divisions. Sugar manufacturing plants, it is divided into following divisions: agriculture, sugar machinery, cogeneration, distillery, biocompost, operation, special products, general heavy engineering.
Agricultural Division. In Agriculture Division, Bouvet Engineering Limited gives support to the farmers and industry for increasing the yield and recovery of the crop with advanced techniques, starting from seed generation to harvesting and transportation of cane to the processing facility. Generation of seed by tissue culture method. In tissue culture lab, we generate the variety of plantlets of any plant, absolutely disease-free, biohygienic and scientific way, especially for sugarcane. In any tissue culture lab, apical meristem technique is used. We wash the glasswares with ordinary water and rinse with chemical. After sterilizing the glassware, different type of medias are prepared as per variety of crop in media preparation room at a constant temperature of 16 degrees Celsius. After storing it for 2 days in 50 ml bottles, it is shifted to inoculation room and kept for 20 to 25 days. When first generation takes place, these bottles are transferred to the incubation room having temperature of 24 degrees Celsius. First generation of plantlets are being multiplied in incubation room in 4 stages in 150 days. These plantlets are converted in spouting stage and finally in routine stage. Routine stage plantlets are transferred into greenhouse in a tray and finally in polybags. Plantlets in polybags are planted in a scientific way, maintaining the gap of 1 feet between plant rows. The whole procedure of development takes about 7 to 8 months. Preparation of land and cultivation of crop. We have to prepare the land for sowing disease-free plantlets produced in tissue culture lab by maintaining the pH of the soil by using lime powder, green manure and biocompost. Biocompost is generally made from filter cake, a byproduct of sugar plant. After plantation, bud generation takes place in 7 to 8 days to the extent of 98%. Organic manures in the form of biofertilizers are applied after bud generation. Use of biofertilizers with irrigation techniques. There are number of biofertilizers named Acetobacter, Innophos, Innopotash, Innodecomposer and compost culture. These are to be applied for achieving maximum yield. Biofertilizers are made by soluble bacteria mixed with media. After inoculation, these are kept in shaking for 72 to 90 hours and finally diluted in 1:5 ratio. The shelf life of these biofertilizers is 1 year and doses are about 10 kg per hectare. These are used once in 2 months and cannot be used after applying chemical fertilizers or insecticide. While using biofertilizers, we should also concentrate on irrigation techniques. After 4 to 5 months of sowing, we have to manage the pest, disease and weed control till 10 to 12 months. Harvesting, loading and transportation. At the age of 12 to 14 months, crop is ready for harvesting and it can be harvested by manual or by mechanical means. During harvesting, trash should be taken out. Sugarcane stems should be loaded in the vehicle by manual or by mechanical means for transporting the crop to the processing facility. By using these scientific methods, we can achieve the yield of 80 to 100 metric ton of cane per hectare with 12 to 16 pole.
Sugar Machinery Division. In this division, Bouvet Engineering Limited undertakes designing, manufacturing, supply, construction and erection of complete sugar plants on EPC basis. The brief overview of our facilities. Marketing and Engineering Office at Pune, Marketing and Engineering Office at Yamunanagar. View of Unit 1. Machine Shop at Unit 1. Stainless Steel Fabrication Bay at Unit 1. Machining facilities of Unit 1 at a glance. View of Unit 3. Fabrication Bay at Unit 3. Machining facilities of Unit 3 at a glance. view of Unit 2 at Yamunanagar. Company has innovated and successfully developed items for sugar industry. Continuous pan for A, B and C massacute. Falling film evaporators. Static type fluidized bed dryer for drying sugar. Massacute filter typhon for separating sugar particles from massacute by vacuum. Company has a long list of satisfied customers. Few of them are Paris, RSCL, GMR, Mashkoor Sugar, Bajaj, Rana Sugars, Shivaratna, Bhel, BEML, NPCIL, Bhavini, BARC, DRDL, ONGC, LRDE and Danili. Bouvet Engineering has successfully completed orders in sugar industry. Processing of sugar from sugarcane in one-off plant supplied by company on EPC basis. Milling section. After harvesting, the cane is brought to the processing facility and is weighed before unloading it with the help of cane unloaders or by truck tippler. Cane unloader places the cane on a feeder table to feed it on main carrier in a uniform and controlled manner. With the help of cane preparatory devices, namely cutter, leveler, fibrazer or shredder, cane is cut into small pieces while it is conveyed towards mills is called as prepared cane. The quality of prepared cane is measured in terms of preparatory index, which is usually maintained at 85+. This prepared cane is passed through milling tandem to extract the juice. An efficient milling tandem should maintain the performance parameters while crushing the cane having 14% fiber. Primary extraction 72%, reduced milk extraction 95 to 96%, bagasse pole 1.8 to 2%, bagasse moisture 48 to 49%, boiler and powerhouse section. After the juice is extracted, the residual cane is called bagasse and used as a fuel in boilers to generate the steam. Nowadays, high pressure boilers are used so that the electricity can be generated by feeding this high pressure steam to the turbine. Whatever exhaust comes out from the turbine is used in the process house to produce sugar. Usually high pressure boilers having pressure up to 110 kg per centimeter square are being used, and extraction cum condensing turbines are used to produce power. An ideal sugar factory should have a power consumption of 28 to 32 kilowatt per ton of cane. These types of plants are called cogeneration plants and are being controlled by DCS system. Boiling house section. The juice extracted from mill house is pumped through a flow meter to juice heaters for heating. This heated juice is sent to juice sulfiter for purifications with the use of milk of lime and sulfur dioxide. Sugar factories produce their own milk of lime by using quick lime at lime station and sulfur dioxide by burning sulfur in the sulfur burner station. After heating the juice in 2 to 3 stages, it is sent to clarifier, where the mud is taken out from the juice. Clear juice is then sent to evaporators, whereas the mud with certain quantity of juice is sent to rotary vacuum filter for filtration. In this process, whatever juice was left in the mud is taken out, and the residual called filter cake can be converted into biocompost organic manure by putting up a biocompost plant. The juice received from clarifier is again heated into evaporators under vacuum and thus converted into syrup during process. The syrup is processed again for removal of color in syrup sulfider. Syrup is then taken into pans for boiling, working under vacuum to create grains in the massicute. This massicute is dropped into crystallizers for cooling, and the crystallization of sugar particles takes place. The material stored in the crystallizers is processed in the centrifugals to separate sugar crystals from massicute. The residual material is called molasses, which is sent to molasses tank. Alcohol or ethanol can be produced with this molasses. The sugar obtained from the centrifugals is dried in fluidized bed dryer with the help of hot and cold air. Sugar is segregated into 3 categories called large, medium and small, depending on the size of crystals, using the grader, and is stored in bins. The sugar stored in bins is then weighed and packed in jute or HDPE bags. The sugar so produced is called white plantation sugar. Some countries need refined sugar. For that, the raw sugar is reprocessed by phosphatation process, and the color is removed by using resin columns instead of sulfur dioxide. This sugar is called refined sugar.
Distillery Division.
Our technical partners, Messrs. Reunion Engineering Limited at Brazil, designed, erected and commissioned the distillery of 600 KLPD.
Final molasses, a byproduct of sugar plant, is used for making the rectified spirit, alcohol, extra neutral alcohol and ethanol in distillery. Final molasses, called mother liquor from sugar plant, is fermented in fermenters with the help of yeast class fungi. During fermentation, the sucrose content present in mother liquor is converted into glucose and fructose. During the fermentation process itself, it is finally converted to ethyl alcohol. Lot of heat along with CO2 is generated during the fermentation process. The excessive heat is controlled by circulation of paint wash in fermenter coolers. The additionally generated CO2 is passed through CO2 scrubbers having water. CO2 gets absorbed in water, and this water is used in fermenters for dilution. The liquid received from fermenters is taken to distillation column for distillation having 3 stages. Distillation in 2 stages takes place under pressure, and in 3rd stage it is under vacuum. The vapor generated in these columns goes to condenser for condensation and is purified in hydrocolumn. The purified liquid so obtained is rectified spirit. By further processing of rectified spirit in rectified columns, extra neutral alcohol is obtained. ENA is cooled down to 30 degrees Celsius with the help of coolers for storing. By further processing industrial alcohol, ethanol is produced. Biocompost Division. The press mud or filter cake received from filter station of sugar plant is decomposed as biocompost and converted into manure. Spread the filter cake on the ground to reduce the moisture of the cake from 75% to 40% through sunlight. Spray the paint wash coming from distillery on the filter cake for generating the bacteria. This process takes 2 to 3 months. Once the bacteria is generated, it is again stirred with the help of mechanical system and sprayed for drying. The product comes out after drying is known as biocompost manure. Once biocompost manure is dried, it is fed to the screening machine, where it is screened and the good quality of manure is bagged and waste manure is again recycled with press mud. This manure is very good for sugarcane crop, especially at time of preparation of land.
Operations Division. Bouvet Engineering undertakes supply of trained manpower to the customer for running their plant. Bouvet also undertakes operations and maintenance of the plant on the contract basis for 5 to 10 years. During that tenure, we train the workforce of customer so that they can take up the operations and maintenance smoothly once our contract is completed.
Special Product Division. Special Product Division was started in 1999 to serve the nation by manufacturing and supplying special purpose equipments and machinery required by defense laboratories, Department of Atomic Energy, Indian Space Research Organization. Some of our main products are Department of Atomic Energy, for defense laboratories,
General Heavy Engineering Division. We are providing our services to many OEMs and end users of cement, steel, material handling, paper, and general heavy engineering companies. We are also manufacturing the jobs or equipments as per customers' design and quality norms. The equipments are manufactured as per ASME standards for material selection, material testing, welding, fabrication, heat treatment, machining and testing. We are equipped with all kinds of NDT testing, hydro testing and pressure testing facilities.
Thank you.